Welcome to Chapter 6, Energy Cost of Physical Activity. This is one of my favorite chapters in this book. I love doing these calculations. So sometimes you'll hear me refer to them as metabolic calculations, but what we're going to do is learn how to calculate the cost of physical activity. Have you ever been on a treadmill? Well, before I ask this question, can you give me 3 specific applications related to the cost of physical activity? So what are 3 reasons or specific applications related to calculations? Well, the one which is I was going to ask you is, what do you do if you're on a treadmill and you see your caloric expenditure, or you're done walking and you look down at your watch and it says you burned 312 calories, or if you went on a run and it said you had burned 102 calories. How does the watch know? Well, it knows because it knows your speed, it knows your body mass, it knows any elevation changes. So it can use some of the formulas that we're going to go over to calculate. Now, specific applications. Well, if you have somebody that's interested in weight loss and there's a recommended amount of weight to lose over a certain period of time, you can do these calculations. In fact, I'll show you examples of those. So for this chapter, I'm going to give an overview and some specific examples. I'm going to break it up into multiple sections, and then I have some supplemental videos if you are, say you haven't had math in a while and you don't know how to cancel units, or you don't know how to convert pounds to kilograms or miles per hour to meters per minute. So when I'm going over these, if there's a part of the equation that you don't really know, look for those supplemental videos, and that'll help you out quite a bit. Okay? So our goals are to explore the application of metabolic calculations. We're going to determine components and commonalities. So what are the different measures necessary to do these calculations? And then, are there any commonalities? If you think we're going to do walking, running, with and without incline, we're going to do cycle ergometers, and we're going to do caloric expenditure for a variety of activities. Now, to learn them individually, I mean, it's certainly doable. But to think about, hey, what do we have in common? So I'll tell you, if you are walking or running, you need to know speed. You need to know if there's an incline, and you're always going to add rest. So I'll get into specifics about that. But this is a cool. If you don't like math, what's great about this is it's math that's actually usable. So you can go, oh, okay, now I know why I went over that. Now I know why we use negative exponents. This is because it does a certain expression for rates. So I'm going to go over that. Hopefully it'll be an enjoyable experience for you. So we're also going to calculate caloric expenditure. We're going to look at the estimated cost of walking, jogging, running, and we may or may not do bench stepping. I think that maybe we won't. And then we're going to look at estimating the oxygen cost of arm or cycle ergometry. It covers that in the textbook, but I'm not going to ask you to know that for any tests that we have. All right, so how can we express energy expenditure? One way is to do it by VO2, which is liters per minute. We can calculate energy expenditure or express it saying kcals per minute. We can do it for VO2, which is mils per kg per minute. So VO2 in absolute terms is liters per minute. So my absolute VO2 is probably 5.5 or 5.2 now liters per minute. Relative simply means I divide my body mass, which is mils of oxygen per kilogram of body mass per minute. And so relative VO2 is the best for comparing people of different sizes. So if we want to look at averages and norms across populations, sometimes we use relative VO2. METs is another great term. A MET is a metabolic equivalent. So right now, everybody is at 1 MET. So 1 MET is your resting metabolic equivalent. If you're at 10 METs, then you're 10 times your resting metabolic rate. If you're going to do research on physical activity, if you're going to make statements about the effects of physical activity, one way to take a variety of activities and find a commonality is to change them into METs. You can use the physical activity compendium to do that. We're going to look at kcals per kilogram per hour. That's another measure. So there are multiple measures for looking at energy expenditure. So one of the reasons why we use METs, because we can take different activities and express them and compare them. But also, too, if we know METs, then there's a very easy way to calculate total caloric expenditure. We can calculate kcals per minute, and then if we know the number of minutes, we can get total kcals. So we know that 1 MET is the energy cost of a person at rest, and it's equal to about 1 calorie burned per kilogram of body weight per hour. So if we know body mass, then, and we know METs, we can calculate caloric expenditure. 1 MET equals 1 kcal per kilogram of body mass per hour. So here's how you can calculate caloric expenditure if you know METs. So determine the MET value. Multiple ways to do that. One is to look at the physical activity compendium. Also, too, you can calculate that. And so I'll show you examples of that shortly. Then you're going to multiply by the body weight in kilograms. So we're always going to convert to kilograms. To go from pounds to kilograms, you divide your body weight by 2.2 to determine your weight in kilograms. So if you're 220 pounds, which you're probably not, you divide that by 2.2, you get 100 kilograms. So you take the result and divide by 200 to determine your calories burned per minute. Let me show you an example of that. So if we have someone who's working at an intensity of 10 METs, so METs will be given to you or you'll need to calculate it. In this example, it's given to you. So they're 10 METs and they weigh 180 pounds. First thing you do is change 180, divide by 2.2 to get 82 kilograms. Then it's simply METs times 3.5, which is a constant, times body mass, which is 82, divided by 200, which is a constant. That equals 14.4 kcals, or 14.4 calories per minute. If they ran at this pace for 30 minutes, then they would burn approximately 432 calories, or 14.4 kcals per minute times 30 minutes equals 432 calories. Let's do a practice problem. So if you want to pause this and then try to work it on scratch paper, and then I'll go through the process and you can see if you get it right. One thing about math is you can't go, okay, I understand it. You actually need to write out some of these practice problems. If you were in class, we would be doing a ton of it. So you pause this and see if you can solve it. So here's the question. A 30-year-old man weighs 170 pounds, which is 77.3 kilograms. He performs 45 minutes of running at a speed of 7 miles per hour. How many calories is he burning per minute, and what is his total calorie expenditure? So remember the formula. Do you have that memorized? You don't need to convert to kilograms. I've already done that. Plug in your values. So What is his MET value? Because we need to know METs. Well, it's not given. So what can you do? You can look at the physical activity compendium, and you'll see that running at 7 miles per hour equals 11 METs. If you don't know what the physical activity compendium is, then make sure you watch my videos from Unit 1. So we go 11 METs times 3.5, which is a constant, times body mass, which is 77.3. Divide that by 200, we get 14.9 kcals per minute. If we know kcals per minute, we know that he was running for 45 minutes, so total kcals equals 14.9 kcals per minute times 45 minutes. This person burned 670.5 kcals running for 45 minutes at 7 miles per hour. Did you get that? So before I talk about commonalities, I'm going to take a break. Keep this first part to 12 minutes. So stay tuned for part 2. We'll learn some other ways, a general way to look at these problems, and then we'll actually do some more solving and some more calculations. So I'll see you shortly.